But yeah, welcome everyone to roll call number 6. That is issue 1071 in the PM repo. Link in the chat. First thing to touch on is the blob base fee spike that we saw on June 20th. I think, first of all, this was largely something that was due to organic demand. Like this was just genuinely people using the chain as intended, and L1 responded as expected, which is good to see from an L1 perspective, but obviously sucks if as an L2 you ended up way overpaying for posting blobs in a certain amount of time, if that wasn't what was intended to do. I think as many people are aware here, we have the DAS upgrade coming up in Pectron L1, that's EIP 7594, which should hopefully help alleviate some of these things. And there was a breakout call yesterday on PeerDAS, and one of the topics discussed there was potentially not having the target be half of the max, which depending on how we set parameters there could also help. I'm not aware. I wasn't on this call. I don't know if anyone here was. Does anyone know what the current thinking is around target and max?
I'd like to just point out that I was looking into the blob incident, and I don't think the L1 was working as expected.
Oh,
I found an issue with how. Well, I guess it depends, where you say the issue is. But the way the
okay.
get transaction pool works is it rejects blob transactions with gapped nonces. In the way OP Stack works, anyway, is it only sends batcher transactions it only accepts them from a single address. So when the batcher gets behind, it will submit multiple transactions with consecutive nonces. And ordinarily that would be fine, but it also turns out that Geth has a non-deterministic order in which it announces and requests blob transactions. So if it were to request them out of order, one of them would be immediately rejected and then not further propagated. And so I believe that was leading to propagation issues, because what we were seeing is we were continuously increasing the priority fees of our transactions, and they would just kind of disappear. And I believe this is the cause of it. I've posted a PR for Geth there. I don't know if that was affecting non-OP Stack chains, but I'm pretty sure it was affecting our ability to land transactions anyway, especially when it started getting behind. We had our system configured to submit up to 5 transactions at a time, and of course, the more parallelism you have, the worse this issue tends to impact you. So that's just a recent finding I wanted to share. I don't know if it affected other chains, but it was certainly a big issue in base. We had we were perhaps, I think, 3,000 blocks behind at one point, trying to catch up, and that is why we ended up overpaying. Also, because at the point we started posting the batcher transactions, we were including L2 transactions that had been submitted much earlier, and we're only charged for a much lower blob base fee. So all these kind of things conspired to just kind of fed into each other.
Okay, yeah, that's definitely some interesting things. Yeah, Andres?
Is the non-determinism issue only is that specific to Geth, or is this also a case for like Bezo?
I've pinged the Nethermind folks. I've pinged the Reth folks. I haven't
Right.
asked more broadly. It may well be an issue. The other issue with Geth is it also was not requesting blob transactions right away. So this exacerbated the problem. It would basically wait half a second after the announcement before fetching the blob transactions, which is kind of how it treats non-blob transactions, because it's waiting for them to be propagated automatically. But blob transactions aren't broadcast. So that was another factor in it as well. So basically, it would wait till it got several announcements, and then by that time, the non-determinism was much more likely to happen. So that problem, I think, is specific to Geth. At least it wasn't in Nethermind and it wasn't in Wrath. But the non-determinism part, I'm still trying to understand that. And I've reached out to at least those client teams. But anyway, that's why I wanted to socialize it here a little more.
Light Client, as our resident Geth expert, and comment in the chat. Do you have any thoughts on this?
I haven't looked into this a whole lot, but it makes sense to me. The PR, and I think that we'll merge this soon.
Okay. Cool, thank you. So it sounds like this is the issue here is primarily due to the non-determinism. Am I understanding correctly? Like if the non-aligned non-scaps is generally okay, if we could at least have determinism in how they were fetched.
I mean, that'll certainly help. I mean, because it's networking, you're never guaranteed anything. But yes, that in that PR, exactly the fix is just that, to just try to always request it in order. And I think that's probably good enough. But getting rid of the non-gap rejection would be another fix as well. But obviously, that opens you up to some denial of service issues. So
yeah, and I think that's the bit of the spikiness around the mempool and how the replacements work and all of that for DOS reasons, I think has also produced a lot of the pain that happened during this event. Things like needing to double the fees to replace is, yeah, not great. But needed on the one side quickly.
Just a quick question, just my stupidity. Why are the block transactions not announced? Just like regular transactions?
why are they not broadcast, you mean?
Yeah, immediately.
It just because they're much, much larger than ordinary transactions, and so we didn't. The decision was not to eagerly broadcast them, which results in some amount of redundancy. So by not broadcasting them, you're guaranteed to only fetch it once, minimizing your.
Okay. Would it make sense to have a digest broadcast, so then you fetch it, but at least you know that it's there, so you're not running into that issue that you're all of a sudden like, oh wait, they're like 10 transactions.
Yeah, that's not a bad idea. There is this metadata that does come with announcements. Right now, it contains the transaction type as well as the transaction size, but it does not include, for example, the sender and nonce. But not sure that's going to be necessary. Perhaps we'll see after this fix whether we encounter similar issues.
So one of the other proposals that's been floating around, or one of the other things that's been mentioned a bunch, is the fact that because you can include multiple blobs per transaction, it becomes very hard to pack blocks from like a knapsack standpoint. And additionally, I think that's a large cause of the conservatism with which the L1s are treating the blob mempool. Obviously, it's not a like longer term fix, but like, would people, or is there any interest in potentially having some like agreement amongst L2s to not post multiple blobs at once per transaction? Would that be something that people would be interested in? Obviously, it means that you can't amortize the base transaction fee across as many blobs.
I mean, I think that's something we would be open to. In fact, we did try to turn the number of blobs per transaction down during the incident, thinking it would help. But unfortunately, because of the other issue I just described, it made that one even worse because we had to submit more parallel transactions at a time. But once that issue is fixed, I think that is a reasonable thing to implement. Right now, I think Base is submitting 5 blobs at a time. It usually means we're paired up with Tycho, which is usually sending 1 blob at a time pretty consistently. But this is a parameter. No issues with changing it. it still works.
Yeah, I think it's largely a case of like, it might not necessarily be like, it's not necessarily helpful if only 1 or 2 people change, but if we can get most people to change, and it makes it much easier to make these decisions. Because I mean, sure, the knapsack is one part of it, but if we can just be more conservative in these things, then maybe we can change the mempool rules around how these things get like what's required as a replacement fee as well. I.e., if you only have 1 blob, then you could have a low replacement fee, or as also has been discussed, having another endpoint which doesn't replace the entire transaction, but sort of just the header with the priority fee. But I think that would be a bit more invasive. Okay. One of the other interesting things I found out while doing a bit of digging here is, I think some figures have been pointed around at Flashbots as builder for not accepting blobs as a compounder on this. But doing a little bit of digging, it looks like Flashbots is only at 2% of blocks. So I don't think that has a major impact on the total amount of chain throughput, although obviously not good to have. And they have subsequently started accepting blobs again. It's just interesting to see. Okay.
Yeah, they had claimed it was a bug, and that it's apparently been fixed. But what I've been sort of tracking the number of blocks with 0 blobs,
Mhm.
and it's gotten better. It was 40% during that incident, and now it's 36-ish percent.
Okay.
So it is dropping. Actually, I just checked it right now. It's down to 34%. So it does seem like some builders are being a little more eager with blobs, which is good news.
Mm-hmm. Do you have data into that per builder?
No, I haven't done any recent analysis breaking it down. We did it for the during the incident, but since then, all I've checked is to make sure that Flashbots has started to accept them.
They definitely have. I've seen data where they have.
Yep.
Yeah. I'm just curious as to see what's the remaining 34% or whatever you mentioned.
Yeah, I don't have the breakdown, unfortunately.
Okay. All right. Any further items that people would like to discuss on this topic? Nope. Okay, moving on. There's what was this? Elias wanted to raise some his RIP on L1 load, but I don't believe he's on the call. Or anyone else who wishes to speak about that?
This was proposed by Icemelon, but I speak on his behalf.
Oh, okay, cool. Yeah. Do you want to speak about that for a little bit?
Yeah, I have a short presentation. If that's okay, I will share my screen and go through that.
Yeah, sure, that's fine.
Seems like I don't have permission yet to share.
You should now.
Okay. Can you all see my screen now?
Yep.
Send it.
Okay, thanks. I also share this presentation in the chat for your reference. So hey everyone, I'm Peter from Scroll. We recently proposed RIP 7728 called L1 load precompile. So I want to take a few minutes to walk you through this proposal. The idea of this precompile is to make it easier for L2 devs to use any L1 state without having to care about MPT proofs. We do this by introducing a new precompile that we call L1 load, and basically this is just a simple interface over ETH get storage at, and this is a service that the sequencer kind of provides to dEPs on any L2 network. The proof verification is not something that dEP should care about, but it's left to the sequencer and to the provers. And we believe that this is a simple building block that makes it easier to build any cross-chain dEP between Ethereum and the L2. There have been some similar proposals before. Tycho proposed RollCall, and I think Optimism a similar one called remote static call, which are in a way more powerful because you could have like a full EVM call context in those proposals. But at least in our experience at Scroll, this is not really feasible to implement at this point because we would need to have like ZK EVM embedded with less powerful but less fancy, but something more feasible in our view. The spec is quite simple. So this will be a pre-compiled that simply takes the contract address of an L1 contract and up to 5 storage slots. So this 5 is kind of an arbitrary number, and we'd love to hear your thoughts on this. And then it issues a batched RPC call to an L1 node and then returns those red storage slots to the L2 caller. So here's the details, but it's fairly straightforward. Just the encoding of the inputs and outputs. In terms of gas, so we have a fixed gas cost and a per load gas cost, which is based on this K 1 to 5 constant. These are not the final values, but our current thinking is that the fixed gas cost is around 2,000, and the per load gas cost is picked selected to be the same as S load gas cost for cold slots. The fixed gas cost is quite interesting because this time the main cost, I would say, is latency, the RPC call latency, which is not a resource that we have experienced pricing as opposed to storage or compute. So this is really not final, this number here. Yeah, to answer Richard's question, currently is only called. I guess we could consider, within the same transaction, if you read the same slot twice, then the second time we can just read it from local cache. But I think that's not really something that dApps would use quite often. So I'm not sure if that's useful, but we can incorporate that into the RP. From a dev perspective, this would be quite simple to use. You can just static call, provide like a list of keys and the address, and then use ABI decode to decode the results, and then use that. So quite developer friendly, I would say. In terms of implementation, we have an example implementation. I wouldn't call it reference implementation because the RIP, gas cost and some other details are not finalized yet. There's 2 things I want to highlight here. One is that we assume that the L2 node connects to an L1 archive node. I think it's a reasonable assumption that the L2 node connects to an L1 node, but requiring it to be an archive node might be a stronger requirement. That is kind of an issue with this RIP. So the sequencer would need to execute a recent L1 state, so a full node would be enough here. But any L2 follower node who wants to replay historical transactions would need to connect at least temporarily to an L1 archive node, and then they could switch over to an L1 full node if they don't want to maintain that long term. The other prerequisite is that the L2 protocol has a notion of the latest seen L1 block number. We at Scroll have a spec for this already, not live on mainnet yet. Optimism also has a system contract that has this. I'm not sure about other rollups, but I think this is generally something that's useful in many contexts for rollups. So it seems to be a reasonable prerequisite to have. In terms of implementation, I have it linked here. We have a Geth fork for our sequencer, and we have this example implementation in that Geth fork. And then the verification part is basically we would do sequencer, or the rollup would do the verification of the proofs on behalf of the user. So that would mean that at proving time, so at sequencing time, you can just call the get storage at RPC, but at proving time, you would need to get the corresponding state proof, and you would need to verify it in a ZK rollup inside a ZK proof or inside your fraud proof mechanism to make sure that all these reads were performed correctly. One of the concerns that we heard is the latency, like how fresh is this state that is available to L2 dApps. I think Vitalik mentioned these different stages. So the most conservative one is if the L2 rollup only imports finalized blocks, which is safe. You don't need to care about reorgs, but the latency is not great. If you wait for 10 confirmations, that would be stage 1. That's much better UX, and the risk is not huge, but you need to be able to handle reorgs in the worst case. And then the best would be just almost no latency, or like 1 or 2 slots. But then reorgs is something that you would need to deal with quite often. So how we relay this L1 block information to L2 is not really in scope for this RIP, but this is an important consideration nevertheless. And then finally, there are a few open questions. The first one I already mentioned: is it okay to require L2 nodes to connect to an L1 archive node? As I mentioned, for the sequencer, this doesn't seem to be necessary. But as someone mentioned in the Telegram group, currently it's not even necessarily required for L2 Floor nodes to connect to an L1 node at all. You could just get the same information from the sequencer. Of course, you would need to trust the sequencer on this, but it's not a strong requirement now. Whereas for this RIP, it's definitely necessary to at least connect to an L1 full node to be able to follow the chain. Dealing with the RPC errors is also an interesting question. Since these calls to this precompile are part of the state transition, you need to make sure that you deal with these errors in a deterministic way. So our proposal now is in the sequencer, you can retry or reject the transaction, but once it's included in the ledger, the only thing that nodes can do is retry. So if your L1 node has a connection issue or whatever, then you need to retry until this call succeeds. Otherwise, you cannot reproduce the state. There's the question of RPC latency. So one aspect of this is how do we price this in guess, and also whether this will become a bottleneck for the sequencer. We think this is probably not an issue because the sequencer would definitely use the local node. So latency could be optimized. It wouldn't call like Infura or some remote service. But for follow nodes, this might be significant latency if they use some third-party service. The fourth one, again, this is what I mentioned on the previous slide. The more recent state we can expose to L2 depths, the more useful it is. And indeed, some depths might want some guarantees that the state that they can read is recent and not from 2 months ago. As for the guarantees, we don't have a great answer here. Although I mentioned this is not really in scope for this RIP, but this is definitely something that affects its usefulness, and would love to hear your thoughts on this. The proving overhead, we can only speak for ourselves in Scroll. For us, the MPT verification for L1 proofs seems to be acceptable. It's something that our provers can manage, and this is basically the main selling point of this L1 slot compared to the previous L1 call precompiled that I mentioned, that this is feasible in the ZK context and that one is less feasible. And finally, a previous version of this precompile allowed reading state from an arbitrary L1 block height, or at least the last 200 blocks or something like that. We removed this for simplicity, but some people suggested that if we allow tabs to specify the block height, then this might enable some use cases that are not possible otherwise. So this is also somewhat of an open question whether we should add this to the input list or not. If you want to try it out, we currently maintain an open DevNet, so feel free to take a look, to interact with it, call this precompile. And finally, we have the RIP and the discussions linked here. So that concludes the presentation. Are there any questions?
Thank you, Peter. Have you had any, like when you talk about the dealing with different latencies, and whether you use only finalized blocks or more recent things, and you talk about just having to deal with it, who's dealing with it? Are you imagine this being on the DApp side or on the L2 side?
You mean the latency for relaying the blocks from L1 to L2?
Yes.
So this is something that the rollup would also provide for the users. And as I mentioned, Optimism's L1 blocks contract is an example for this, already live, I think, on their mainnet. But this is not part of this RIP.
Okay.
Yeah, I think this is more like a prerequisite to the L1 node.
Yes, but my question is, you said that people have to deal with it, but I'm asking who you're envisioning dealing with it. Is this something that you expect L2s to have? Sorry, the contracts deployed on L2s to have to like handle reorgs if they happen?
Oh, no. So this would be handled by the sequencer. So if you rely on any L1 state that was reorged, then the L2 ledger would need to reorg accordingly.
I see.
If you relayed any information, that could be deposit messages, but L1 block hashes also belong to the same category. If you relay that and it's not true anymore, then you will need to reorg accordingly.
Okay. Thank you.
Yeah. Adding one comment here is that we think like the to make the L1 slot more useful, like to the developers, it should be like the using at least like at a stage 1. So because like otherwise reading a very like long latency, we're making like the developers and an application read a very stale state. So might like the limit the use cases for this precompile.
Outside of sort of base rollups, is this reorging the L2 based on L1 reorgs? Is this infrastructure that already exists in some L2s?
So I believe Optimism has this state derivation function. Based on that, they can definitely kind of deal with reorgs. At Scroll, we're working on this functionality. Currently, we're still stage 0. We just wait for finalization. But I don't think this is anything inherent to base rollups. Non-base rollups can also have this functionality. But I'm also curious.
Totally. It's just a
to hear
requirement
from
for
other
base, which is why I was asking.
Yeah.
Any further questions on this topic? Nope. Okay. Well, thank you very much, Peter. And then next topic, I believe, is Richard wanted to talk about RIP 7740, pre-installing deterministic deployment factories.
Yes, and I mean, it comes out from a actually pretty old thread over a year ago or 2 years ago, pre-RIP time basically, where it was talked about should there be a precompile for Create 2 so that it can be used by UAAs across chains, and at some point then they're basically and get to the point that some of the rollups, namely Optimism, started pre-installing some of the workarounds for this non-existence of the precompile for Create 2. There were a couple, I think, like I listed them in the RIP. There are a couple of factories also used by Safe. We used multiple ones so that we can utilize them for deployments, right? And what we realized is that it's still a little bit of a hassle, and actually also one of the bottlenecks. If we deploy them, we have to make sure that is such a deployment is our deployment factory available, because only this allows us to deploy to the same address with the same security assumptions in all places. And it's actually not only a problem for us, but for a lot of other teams. For example, Coinbase is also utilizing our factory. There are a couple other factories being written, and it's not always possible to use the one that is trustlessly deployed due to certain gas trade-offs, gas pricing and gas limit trade-offs. That is one part, and the other part, which extends actually on this problem, is that currently, so up till now, there was no unified way across all rollups, including the ones that are not type 1, type 2. So for Optimism, Arbitrum, and Polygon, and all the ones based on these stacks, there it's possible that you just redeploy the contracts, the factories that you have in one way or another. But when you think about ZK Sync, for example, there's currently no way to actually get this done because Create 2 obviously depends on the bytecode, and bytecode is just different. And so these two problems would be nice to push them forward in a way that we can say, hey, this would be a major benefit if you deploy cross-chain protocols, if they can be at the same address, if you can, especially for smart accounts, enable the same address or like deployment to the same address. These are just nice, at least security properties, but can also be used for UX properties, right? And this is basically where what I wanted to figure out is it even realistic to get alignment from the rollups on this one? Or do they say, no, we basically would have to try to get each of the rollups individually to commit to certain pre-installs for this one, and then also not sure if anybody actually from the ZK Sync stack is here or any of the non-type 1, type 2 stacks, not sure which other teams there. Also, is there a willingness to look into figuring out how we could bring or build a solution that goes across, like that works also there? These are the two questions for me before I would like to push this further forward. I want to avoid that it's basically a battle against windmills or whatever you want to say, however you say it in English. So not sure who is the best to respond. I mean, the first question, is there a general willingness to define such a list of pre-installs that, I mean, there are to some extent already present on most of the rollups. It would be more formalizing this for new rollups spinning up based on existing stacks. That would be my first question, basically. Is this realistic, or is it something that is very unlikely to get through?
I'm curious, by pre-install, do you specifically mean Genesis pre-deploy, or you don't care about the deployment? You just want to make sure that these are available on each rollup?
Simplified speaking, I don't care about the means. They should be available on each rollup at the same address, basically, with same logic. I think Optimism, the one I referenced was Optimism. That's why I used pre-installs, where it was then basically from the get-go. But in the end, if there are other more or easier ways or more feasible ways, I would be fine with this too. I have to admit that I'm not that deep into the rollup space that I would say this is the best approach, and would be happy for feedback.
So interestingly, with Base, I think it was the Create 2 deployer. The person tried to deploy it, not realizing that bridging funds over from mainnet incremented the nuts, and that completely broke it. So we actually had to do a hard fork where we sort of redeployed the Create 2 deployer at the expected address. So this would have prevented that situation. So I just wanted to point out that data point. I do see the value in it.
I also think it's a good idea to have a standard list so that we can track who's compliant and who's not.
That's already good to hear. That would give me at least some motivation to keep this pushing. Then, do we have anybody here from ZK Sync? Sorry to be ignorant on who is working on a project, but else I would have to reach out to them on a different channel. Okay, then maybe I will not be able to take part in the next roll call. It's during my holidays, but I would take it on to either have somebody else represented or join the one afterwards, even though it's a long time ago, like a long time in the future. But then I would try to align with ZK Sync, and then I would try to present a more final version where I would say this is ready to merge since it's currently a draft.
That sounds great. Thank you. I think this is a perfect thing to try standardize here and definitely see the use, but also just to point out that we don't like part of this process is not necessarily having consensus and only one way that is compulsory to do it. Obviously, it's nice if everyone agrees, but if we end up with outliers, it's too hard to include them. That's also okay. If you ship a standard that is mostly used or somewhat used by a subset, that's still an improvement over the baseline. Great, thank you, Richard. Okay, I believe those are all the agenda items we had. Does anyone have any other items they'd like to discuss? Going once. Going twice.
I had suggested to discuss a breakout session about the L2 transaction fee spec.
Yeah. Sure. Should we do that async?
Well, I mean, it's like I mean, the spec's there, right? We would like to get some feedback from client teams, so I think it would be good to actually schedule that. Yeah, but yes, we can do it async, but as long as it's getting scheduled.
Sure. We can make sure that happens.
Okay.
Cool. All right. Any other topics?
Oh, just one last thing. There was a discussion thread around L2 transaction statuses and the fact that they're not standardized in any way, shape, or form. So
What? So A, where was this happening? And B, what exactly do you
in
mean
the
by
roll call.
transactions?
Sorry.
Oh, okay. Yeah.
In the RollCall Telegram group, because there's no common definition what different statuses, even if they're different, mean, right? I mean, you can maybe call it different things, but it should the meaning should be the same, if not the words, even though the word should also be the same. So that we have equivalent to HTTP codes that is clear what they mean, right? So the L2 standards working group over on the Ethereum open projects community made a proposal, put that on ETH Magicians yesterday, and also on open an issue in the RIP repo, just to get the discussion going, because I think it would be beneficial to the community if there's a common glossary of these terms that everybody sticks to. And I think it's something relatively simple that could be achieved fairly quickly.
Okay, thank you. Yeah, we can see if there's people are interested in adopting something like that. Any further topics? Okay, fantastic. Thank you everyone for attending, and we'll chat to you next time. Have a great day.
Thanks.
All right.
Thank you. Bye.
Thank you.